Hello, this is Washington, and I will be taking you through an onboarding session of the Launchpad design. So, basically, what we'll do today is basically just the introduction of what the Launchpad is, why it's necessary, what we've done before, and some few tips and tricks. So, in a nutshell, a Launchpad is designed to give the rocket some initial trajectory. Generally, whenever you're launching a rocket, you have a desired path that you want it to follow. So a launchpad just gives the rocket guides the rocket through the initial stages of flight so that it can be able to follow that path throughout its time of flight. So the launchpad has three basic components. The main one being the launch rail and the base. Then we have the launch lug and the blast deflector. So I can take you through the three briefly. So the launch rail, which is this long rail that you can see on my right, basically it's the rail which the rocket is supposed to slide through in the initial stages of flight. The launch lug is the mechanism by which the rocket is attached to the launch rail so that it can slide through the rail, and after that it can continue with the path. The blast deflector is basically a small metallic plate that is used to deflect the fumes and the exhaust gases that are released from the rocket. So we began with a simple launch pad. It was made from PVC. I think this is one of the videos that inspired the previous design. I'll share it. Okay. Yes. So in the previous video, I think it's gone too fast. However, what we had was a PVC-based launch pad that was portable, and it was able to facilitate the launching of a rocket at different angles. So that was basically done for the N1, where we had a smaller rocket with an apogee of 50 meters. So when we went to N2, the apogee moved to 500 meters, and therefore we needed to have a bigger rocket, and we could not reuse the same launch pad. So for this N2 rocket, we had a launch pad that is designed as shown. So this is just a video that shows the basic design of the launch pad. So what we had is a launch rail that was able to be tilted at various angles by means of these slots that you can see at the bottom. The launch pad had a rail that was 3 meters in height, and the base had a wingspan of around 3.5 meters. So some few things and challenges that we had with this launch pad was number one, the very long launch rail had a problem with stability. It kept swaying in the presence of wind, so we had to ensure it was stable by tightening ropes. Also, the base, not the wheelbase, the base that was made from steel tubes, it was not welded properly, so some of the legs broke, especially during the launch, and it was catastrophic. Yes, so basically that was that. So some very important things to note in the launch pad is the launch lug and the rail. So the launch rail is basically any normal rail that you can get. So you need to be very careful in your selecting. You need to find a rail which it will be easy for you to find the mail, that is the lug, to slide inside the rail. Yes, I hope that is not confusing, but basically what you do, you need to fabricate a launch lug which is going to slide inside the rail and allow the rocket to slide through. So when you're selecting the rail, we found a company called Hydro Aluminium in Juja, and they sold us a certain rail. Then from that is how we developed the launch lug that you can see on my left. In the N2 and probably beyond, we used two launch lugs to give more stability to the rocket. We realized that having just one launch lug is problematic because the rocket keeps swaying along its path. Yes, so some few tips and tricks. First, you need to lubricate your launch rail before every launch and even as you store it to prevent rust. Then it's not written here, but you need to have it clean at all times. Then also you need to have an aerodynamic launch leg because it's going to fly with the rocket throughout the flight. Then also, as I mentioned, two launch legs is an optimum, a good idea because it offers more stability. Then also you need to consider reinforcing the base and not relying on its structure alone. Then always make sure you test before and don't test the first time when you've been